Hey, it's Mr. E here. Our aim for this video is how do we apply the properties of logarithms to rewrite logarithmic equations as exponential equations to solve for variables. So if you've been following our series on logarithms, this is part 3 of our series. Okay, as a warm-up, I want you to use the power property to rewrite the logarithm below. After rewriting, evaluate the logarithm. So pause the video and take a minute to do that. Okay, so using the power property, we can rewrite this logarithm as log base 2, 512 raised to the 1/3. The power property allows us to take this coefficient and make it an exponent. So 512 to the 1/3 power, that's going to give us 8. So we get log base 2, 8. So to evaluate this logarithm, we have to use our change of base formula. Basically, our change of base formula says log base BA is equal to the common logarithm of A over the common logarithm of B. So let's rewrite this then as log 8 over log 2. And this is going to give us, let's see, log 8 over log 2, 3. So our final answer is 3. Now, if you're wondering why I didn't just put this in the calculator, recall that the calculator only evaluates logarithms in base 10. So that's why I had to use the change of base formula. The change of base formula allows me to take this logarithm and rewrite it like this so that I can evaluate it using the calculator. This is in base 10 and this is in base 10. That's something the calculator can work with. Alright, so here's our first example. Solve for x. So our goal is to eventually rewrite this as an exponential equation. But before we do that, we have to do a little rewriting. So there's a little rewriting before the rewriting. So let's use the power property to rewrite this as log base 4 x equals log base 4 4096 raised to the 1/3. So the power property allows me to take that coefficient and make it an exponent of that. So 4096 raised to the 1/3 is 16. So I get log base 4 x equals log base 4 16. Okay, this is 16. Okay, now I can evaluate the logarithm on the right side of the equation. So I'm going to use a change of base formula for that. So on the right side, I'm going to get, so that's going to be the log 16 over log 4. That's going to be 2. So I get log base 4 x equals 2. Okay, now that I'm here, I could finally rewrite this as an exponential equation. So I can say, remember, if you're going to rewrite a logarithm as an exponent, follow the arrows. If you recall from my first video, follow the arrows. So you're going to rewrite that as an exponent. You're going to get 4 squared equals x. So that means that 16 is equal to x. And that's our final answer. Okay, now there is a way, of course, to check this, and that would be to take the 16 and plug it back in here and check that the left side of the equation equals the right side of the equation. So let's go ahead and do that. So this is our check. So that's log base 4. Now we're going to substitute for x. That's 16 equals 1/3 log base 4, 4096. Okay, let me just get rid of this so I can have some room to write. Okay, so let's evaluate log base 4 16. So we have to use the change of base formula to do that on the calculator. So that's, okay, we did that already. That's 2. So that's 2 equals, so the left side of the equation is 2. Let's now evaluate the right side of the equation. Okay, now there's a couple of ways you could do that. You could use the power property to bring the 1/3 and make it an exponent of 4096, but I already did that the first time, so I'm going to do it a little different, just to check myself. So what I'm going to do is I'm going to evaluate this first. So that's log of 4096, over the log of 4, the common logarithms, and you get 6. So you get 1/3 times 6. So you get 2 equals 2. So yep, it checks out. 1/3 of 6 is 2. Okay, let's look at our second example. So again, our ultimate goal is to rewrite this as an exponential equation, the way we did in our first example here, when we rewrote it as an exponential. That's what we want to do. We went here, we rewrote it as an exponential, and we got this. So that's our goal. But before we rewrite it as an exponential, we have to do a little rewriting, as I said earlier. So there is a quotient property here that we can use because of this subtraction. So let's go ahead and use the quotient property. That's going to allow us to rewrite this as log base 3 x squared minus 4 over x plus 2 equals 2. Okay, now I could rewrite it as an exponential equation. So I'm just going to follow the arrows, follow the arrows. So I get 3 squared equals x plus 4, excuse me, not x plus 4, x squared minus 4 over x plus 2. Well, that's just 9 equals x squared minus 4 over x plus 2. Let's go ahead and cross multiply, put this over 1. We're going to do some cross multiplication here. And we get x squared minus 4 equals 9x plus 18. So this is a quadratic equation, so we have to follow the steps of solving a quadratic equation. So we got to solve the quadratic. That means we have to set it equal to 0. So we're going to move the 9x to the other side, and we're going to move the 18 to the other side so that we could set it equal to 0. And we're going to get x squared minus 9x minus 22 equals 0. Because moving the 9x to the other side makes it negative, and then moving the 18 to the other side, you get negative 4 minus 18, that's negative 22. Okay, so now we factor. And we get x minus 11, x plus 2, and we get x equals 11, and x equals negative 2. Okay, now, whenever you're working with quadratics, it's always a good idea to check the values you got for x, because you might have to reject one of them. So let's go ahead and do that. Let's do a check to see if anything has to be rejected. And let's begin with negative 2. So log base 3, negative 2 squared, that's going to give us 4, and then 4 minus 4, that's going to give us 0. Minus log base 3, x plus 2 equals 2. Okay, now going back to this, remember I said negative 2 squared is going to give us 4, and then 4 minus 4 is 0. This is going to give us log base 3, 0. Now, this is important. Put that in your calculator and see what it gives you. Log 0 over, because you got to use a change of base. Log 0 over log 3. Calculator says it's not in the domain. So that means that you have to reject negative 2. Let's now check the 11. So that's going to be log base 3, 11 squared minus 4 minus log base 3, 11 plus 2 equals 2. So what we want, hopefully, if we did everything correctly, is for the left side of the equation to equal 2. Okay, so this is going to be log base 3, 11 squared is 121, and 121 take away 4 is 117, minus log base 3, 11 plus 2 is 13. So you get log base 3, 13 equals 2. Let me move this to make some room. Let me just do this. Let me just move this up. I don't think I need more lines after this anyways. Okay, so let's evaluate log base 3 117. Okay, log base 3 117 is going to be log 117 over common log of 3, and that's approximately 4.33. Now let's evaluate this one here. That's going to be log 13 over log 3, and that's approximately 2.33. So 4.33 minus 2.33, is that going to give us 2? Yes, it is. So 11 is our answer. Okay, now I want you to try this one. I want you to solve for x, and this is going to, and I'll give you some choices. The value of x, the correct value of x, is in one of these choices. Okay, I hope this video helps. I apologize that it was a little lengthy, more than usual, but you know, these problems take time. There was really no way around that. I hope this video helps.